Hello children, welcome back to Insightengineacademy. This is physics class, chapter 1, 10th class, reflection of light at curved surfaces. To understand this lesson in a better way, we need some basics that we have discussed in the earlier video. Okay? I hope you have gone through those videos. Now, this is another video that in this video we are going to talk about types of spherical mirrors, terminology related to the spherical mirrors, rules to draw the ray diagrams for the spherical mirrors. Okay, the relation between focal length, radius of the curvature. So many of you, for you, this is all this terminology is very new to you. Pole, center of the curvature, focal length, all those things. Okay, so we will learn all these terminology one by one very clearly. Okay, so let's begin our video. Terminology related to the spherical mirrors. So already we have discussed there are two types of chemical spherical mirrors. One is convex mirror and the other one is concave mirror. Okay, how do we understand concave mirror and convex mirror? You see, this is the curved part. Okay, it has two surfaces, inward surface, outward surface. When inward surface is silvered, then outward surface act like a mirror. This is called a convex mirror. When outward surface is silvered, then inner part, the part of the spherical mirror which bent inwards, this inner part act like a mirror. This is called a concave mirror. The surface of the mirror, the surface which act like a mirror bent inwards, that is convex. The surface of the mirror which act like a mirror which bent outwards, this is called convex mirror. Now I will show you concave mirror and convex mirror. See, this is convex mirror. Okay, so this is the front view of the convex mirror. This is the front view. Generally, whenever we draw the ray diagrams on the board, actually we draw this way. This is the side view of the concave mirror. Okay, so this way. You see, this is the part which is silvered. Okay, and this is the surface which act like a mirror. Actually, this surface is bulged out. See, if we touch, we understand this. Okay, but virtually it may not possible to you, but this reflecting surface some little bit bent outwards like this. Okay, if the same surface bent inside, that is concave mirror. Okay, the reflecting surface which bent outwards, that is convex mirror. Okay, so spherical mirrors are like this. Okay, this is one of the spherical mirror, it's convex mirror. Okay, I hope you understand. Whenever we draw the ray diagram, so generally the side view of the mirror we draw on the board. We don't draw the front view. This is a front view. Okay, this is the side view. Generally we draw the ray diagrams with side view, not front view. Okay. Now, so what is the important terminology we have? So terminology related to the spherical mirror is pole. It is denoted by P. So what is pole? See now, this spherical mirror has geometric center. So what is meant by geometric center? So if you take this duster, so if I place one finger here, so this duster may stable on this finger, right? So this one you see. So geometric center, I want to explain the geometric center. See, when I keep my finger here, okay, so we are able to make this object to stay on end of our finger, right? So this is called geometric center. What is this called? Geometric center. So this mirror also has geometric center. This is the geometric center of the mirror, right? This geometric center or midpoint of the mirror is called pole. Okay, midpoint or geometric center of the spherical mirror is called pole. Okay, I will denote pole here this way. This is pole. Okay, right. I'll write the definition. The midpoint of the spherical mirror is called pole. The midpoint of the spherical mirror is called pole. Okay, so now we are going to understand another important term, center of the curvature. Center of the curvature. So what is center of the curvature? Actually, this mirror is a part of the sphere, isn't it? It's a part of the sphere. So when we complete, this is curved part. When we complete, we get the sphere this way, right? So this sphere has center. That center of the sphere is called center of the curvature. Now I will denote those with the help of the diagram. See, this is sphere. So it has center. The center of the sphere is called center of the curvature. Actually, this convex mirror and concave mirror are the parts of the spheres only, no? So it is a part of the sphere. So center will be here. This is called center of the curvature. So how can you understand that? For example, if you take a plane surface, how many normals can you draw? Normal means perpendicular line. So this is one perpendicular line. 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 Like this, many perpendicular lines, infinite perpendicular lines we can draw. For curved surface, how many perpendicular lines can we draw? Same. If I bend this, okay, I will just apply the force on the both ends of this one. If I bend this, then what happen? All these are going to meet at one point like this. So this is called the center of the curvature. If you choose this point, if you draw the tangent here, the line which is passing through the center of the curvature is perpendicular to the tangent drawn at that particular point. Okay, this is a tangent that we have drawn. Okay, this is the tangent. This is the curved mirror. At this point we have drawn the tangent. Okay, the line which is drawn perpendicularly to the tangent is passing through the center of the curvature. So choose one point, draw the tangent and draw one line perpendicular to the tangent that passes through the center of the curvature. I hope you understand what is center of the curvature. Okay, the center of the spherical mirror is called center of the curvature. I will show you this way. See children, this is this. It's a plane surface and perpendicular lines are drawn this way. Now I am going to apply some force on both ends. So since it is the rubber, I can apply the force. I can bend this. It can bend. When what happen when I apply the force on this? You see, all they are going to meet at one point. Okay, this is called the center of the curvature. So where they are going to meet at one point, that is called the center of the curvature. I hope you understand. Okay, so this is a part of the sphere. Okay, if we complete the sphere this way, center will be here, right? So the center of the sphere is called the center of the curvature. The center of the sphere is called center of the curvature. I hope you understand what is center of the curvature and what is pole. Once again, you see, this is a midpoint. Okay, so this is a part of the sphere. When you complete the remaining sphere, you get the sphere like this. Here the center will be located. If you choose one point on this, if you draw the tangent to this tangent, you draw the perpendicular line. That perpendicular line passes through the center of the curvature. So this is pole. Here also you can draw the tangent, goes this way. If you draw the perpendicular line, this passes through this way. But the line which joins the pole and the center of the curvature, especially it is termed as principal axis. Okay, so another important term, that is principal axis. It is denoted by X. What is principal axis? The line which joins the pole and the center of the curvature. This is also line, but it is not joining the pole and center of the curvature. But this is the line joining the pole and center of the curvature. So this is called principal axis. The line which joins the pole and the center of the curvature is called principal axis. The line which joins the pole and center of the curvature is called principal axis. Okay, so three important terminology we have discussed. One is pole, another one is center of the curvature, another one is principal axis. Once again I repeat, what is pole? The midpoint of the spherical mirror is called pole. Center of the curvature, actually every concave mirror or convex mirror, they are the part of the spheres. If we complete the remaining part, we get complete sphere. That sphere has center in the middle, that is called center of the curvature. Okay, any line, any perpendicular line, when you draw from the curved surface, compulsory that passes through the center of the curvature. Any line, any perpendicular line you draw, that passes through the center of the curvature. How do you understand this is a perpendicular line? Choose one point. There you have to draw one tangent. If you draw the perpendicular line to the tangent, compulsory that passes through the center of the curvature. So like that, you choose some points on this sphere. Once again I will explain, like this is. Okay, let's say this is concave mirror. I choose some points here. Here one point, here one point, here one point. I choose some points. Okay, I draw the tangent. Tangent is the line which touches the circle at only one point. Here also I have drawn one tangent. Here also I draw one tangent. Okay, to this tangent I draw perpendicular line. To this tangent I draw perpendicular line. To this tangent I draw perpendicular line. All these are meet at one point. This is called center of the curvature. I hope you understand. Center of the curvature, it is the center of the sphere. Next, principal axis. The line which joins the pole and center of the curvature is called principal axis. Usually it is denoted by X. Okay, so please note down these definitions. So till now we have discussed pole, center of the curvature and principal axis. So now we are going to talk about radius of the curvature. See, this is the concave mirror. What is this? The midpoint. The midpoint of the concave mirror is called pole. These are the part of the spheres. Okay, the center of the sphere is called center of the curvature. This one, a line joining the pole and the center of the curvature is called principal axis. Okay, so this is pole, this is center, the line which joins the pole and center of the curvature is called principal axis. Okay. Now we are going to talk about radius of the curvature. It is denoted by R. Pole denoted by P. Center of the curvature denoted by C. Principal axis denoted by R. Now radius of the curvature is denoted by capital R. Now it's very simple. Since this is a part of the sphere, right? Coming to mathematics, this is circle, this is a center. You choose any point on the circle and the distance from the center to that point is constant. Choose this point, the distance from the center to that point is constant. Okay, you choose this point, the distance from the center to that point is constant. What is that called? This is called radius. Radius is constant. Radius is the distance, okay, equidistance, which is between the center of the circle and any point on the circle. Okay, our radius also we can understand this way. In a circle we can draw many chords. Okay, so chords, these are the chords. Many chords we draw like this, right? These are the chords. The longest chord is called a diameter. The longest chord is called a diameter. This is diameter. Okay, from here to here, this is diameter. Half of the diameter is called radius. So radius also can be defined this way. Okay, now here also look like a circle and it is a center. Actually it is a part of the sphere. We can't draw the sphere is the three-dimensional picture. Circle is two-dimensional picture. Even though we draw the sphere on the board, it looks like circle only, right? So it is the distance between the pole and center of the curvature is equal to radius of the curvature. This distance particularly, it is called radius of the curvature. Okay, so what is the radius of the curvature? Radius of the curvature is defined as the distance between pole and center of the curvature. The distance between pole and center of the curvature is known as radius of the curvature. Okay, next we are going to understand a very, very important terminology, that is focal point. See, this is the concave mirror, right? This is concave mirror. I'll draw it again nicely. This is concave mirror. The midpoint of the spherical mirror is called pole. It is a part of the sphere. The center of the sphere is called the center of the curvature. A line joining the pole and the center of the curvature is called principal axis. Now I am going to keep one object in front of the spherical mirror. So this is concave mirror. Before concave mirror, I am going to place one object at infinity. Okay, so what is meant by infinity? See, this is convex lens. Okay, I will show you another one. This is concave lens, right? I kept the lens this way. Now I am going to keep one object in front of the mirror. Where I place this object? I will place the object here. If I place the object here, this is also infinity for this object. Infinity means don't imagine very lengthy and long distance, because the aperture of this, aperture means what? The reflecting surface. Okay, the diameter of the reflecting surface is called aperture. I will explain this. This is the front view of our spherical mirror. So this diameter of the reflecting surface is called aperture. Aperture. So since these mirrors have small aperture, the object which is placed here also infinity for them. Okay, you just imagine, compare the size of this universe, compare the size of our earth, compare the size of this one. Okay, So whenever we are comparing the huge objects, this is very smaller. So object which is placed in front of this a little distance also considered as infinity. Okay, now when object is placed at infinity, long distance, already in the previous video we have done the experiment. Whenever the source of light is ahead, long distance, what kind of rays coming to meet the mirror? Parallel beam. We done the experiment with the mobile light. We kept two markers like this and we observed the shadow in the previous video. Okay, once again you watch that video so that you will understand. When source of the light is at the long distance, what kind of rays coming to meet? Parallel beam. Here also when object is placed at long distance, what kind of rays coming to meet? Parallel beam. Okay, for better understanding I will explain with the diagram. See, if the object is placed very close, from here divergent beam is going to incident. Okay, same object if you place at the long distance, from here we get parallel beam. What kind of beam? Parallel beam. So now I am going to keep the object at infinity so that we get the parallel beam. That parallel beam come and incident on the mirror. Okay, after incident on the mirror, what happened? That we are going to discuss. A parallel beam is going to incident on the mirror because object is placed at infinity. So these are all parallel beam. Since the object is at infinity, parallel beam is coming to incident on the spherical mirror. Then what happened after reflection? This concave mirror has a curvature, inward surface. Okay, the reflecting surface is inward, so the light which is incident on it after reflection goes towards principal axis. Here these rays goes this way and these rays goes this way, and finally all the light rays are coming to meet at one point. After reflection what happened I will explain, you see. Okay, so the ray which is incident passing through the center of the curvature after hitting the midpoint of the mirror traces the same path because that is a midpoint. Since it is a midpoint, tracing the same path, it bounces back. And this ray, okay, this ray come towards principal axis and meet here, and this ray come towards principal axis and meet here. This ray come towards principal axis and meet here. This ray come towards principal axis and meet here. All the light rays are meet at one point. That point is on the principal axis. That point is called focus. Whenever a parallel beam is incident on the spherical mirror, after reflection, all the light rays meet at one point. That point is called focus or focal point. Okay, so the next terminology is principal focus or focal point. Principal focus, or it is also called focal point, denoted by capital F. This is focal point, right? Now you see Nana, object is placed at infinity, parallel beam is incident on this mirror. After reflection all the light rays meet at one point. It is a converging lens, that is why after reflection all the light rays are meeting. Okay, see here I want to tell you an important thing. This is incident ray, this is a reflected ray. Now we are going to understand the laws of reflection further. Now I am going to draw the normal. So normal always passes through the center of the curvature. This is normal. So when I draw the normal, the angle between incident ray and normal is called angle of incidence. The angle between normal and reflected ray is called angle of reflection. Here also you see I draw the normal. Okay, here also I draw the normal. Here also I draw the normal. So every time angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Here since the ray is tracing the same path, here angle of incidence, angle of reflection is 0. So here angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Every time light obey the laws of reflection. During the reflection, light obey first law and second law. Incident ray, normal, reflected ray lie on the same plane. Already I explained with these laws of reflection in the previous video very clearly. Once Please watch that video so that you will understand these statements. And angle of incidence is equal to angle of reflection. That is the second law. Every time light obey these laws, even laws are obeyed on curved surface also. Obeyed on curved surface also. Same laws we discussed on the plane surfaces, same laws that also we discussed in the curved surfaces. Okay? Right. Next, I will give you the definition of this principal focus. When a parallel beam incident on spherical mirror after reflection meet or converge at one point, this point is known as principal focus or focal point. So that is the definition of the principal focus. And I am going to tell you the last important term, that is focal length. Focal length, it is denoted by small f. Now we are going to talk about focal length. You see, this is the spherical mirror. What is the midpoint of the spherical mirror is called? Pole, denoted by P. The center of the sphere is called center of the curvature, denoted by C. A line joining the pole and center of the curvature is called principal axis, denoted by X. The distance between pole and the center of the curvature is called radius of the curvature, denoted by R. Now principal focus. When parallel beam is incident, after reflection all the light rays converge at one point. That point is called principal focus. Just now we have discussed. Now what is focal length? Focal length, it's a length, it's a distance between pole and focus. The distance between pole and focus is known as focal length. Okay, so this particular distance, this is known as focal length. Okay, so the distance between pole and focus is called focal length, this one. Okay, I hope you understand all the definitions. Please note down these definitions.